Hello everyone. If I'm audible, can you just write yes and something like that in the chat box? Okay, so let me share the presentation first. So as I mentioned, you need to download the keycard and the GitHub repository before we start. So if you haven't and if you need a time, just can you just text that as well in that text box if you need download the keycard and the GitHub repo. Or everyone has downloaded it, it's checked, so we can begin the just right now. Here are the links if you need. And read as well if we can start right now. If you just write start if we you have downloaded the software and the GitHub repo already. Okay, so as I think you would have downloaded the software, so let me just tell you how you have to import it out in the thing. And if you are more into PCBs, this is the guy who you can refer on YouTube. He basically does the keyboards and micropads thing, but you can just get the brief from it what how to make a PCB and everything. So we can skip this. So here's the part you need to, so first of all extract out the zip file. Let me do it for you. Uh, So uh, so here's the main zip file. You need to extract it. Then it's like it's a bunch of things which are although not required. We just need the extras folder. Some everything from here. We what we need is basically here. So then you just need to open keycard. I want to show you the PPT as well. When you open the keycard, there is a preferences title on the title bar, and you can just click on here the manage symbols libraries. So what you need to do basically in that is okay, so here it is. You need to click on preferences, then manage symbol libraries. Then you need to click here add, and you need to just save the library. I will just share you the PPT as well for it. You need to just press photo. You need to name anything. You can name like I'm using this photo word because I'm just downloading this photo the photo kept library. That's why I've just for the record I have this photo, and in the path there will be a folder icon. You have to click on that and you need to select the exact path is the extract and photo keycard, and then you need to select the like literally every folder here and click open. This is the one of the first steps. Then the second my mic is on. I will just demonstrate here as well. GitHub file is taking much more time to download. Yeah, it will take few times. I can give you 5 minutes. Is it mandatory to use software and project? It's not mandatory, depends on what you are making. Even if you make the hardware, you need to code for the Arduino or the any chip you are basically using. Software, it's not like you won't be using software at all. It depends how you solve the problem. It may be hardware, it may be software. It totally depends on you how you are solving the problem. It can be hardware, it can be software. It depends literally depends. Like for example, you can solve a particular problem using a software app, or someone can solve making a robot for that and hardware. It depends on you. Utkarsh, can you just tell me yes or something like that in the chat box when you are done with downloading? Can you show me the step to on the KiCad downloading? It's not tough. You need to just go to the KiCad site. And we have enough time, so I think I should go from the scratch. This is the main KiCad site. I have shared it already, I guess. Yeah, so this is the main site. I'm using Linux, so I have downloaded the Linux version. If you're using Windows, Mac, everything, you just need to download this and install it. Installation process is very simple. You just click next, next, next. It's more than enough. Then the other thing is you need is the GitHub folder. Uh, the, the name of the repo is. Let me just share you the link as well from the PPT. It will take a lot of time, of course. It is a very big thing. If you want to download selectively, you can just go to the extras folder and select this path and download from here. But it will take enough time because this is a very big repo as well. The basic path we will be using would be this. What actually are we doing? We are doing PC making because there's a requirement in the hackathon that if you are doing a hardware project, you cannot use basic Arduinos. You have to make a particular PCB. Like this is a PCB in my hand. You have to make a PCB, proper PCB. You can submit the keycard file or any file. You can use Flux. A lot of people are using Flux, uses keycard or anything like that. You need to submit that file in the GitHub. I will check it out. Then when we build in the round one, you need to get it done. There are a lot of fabricators in India, China. You can get it in this this combined with six more PCBs cost only 60 rupees to make $1 of six PCBs. Yeah, this meeting is being recorded as well. I will publish it on YouTube. So yeah, we are making the schematic diagram and Jagrit file. Yeah, exactly. When you every one of you have the files, the zip file downloaded and the KiCad software installed, let me know. I will start from then. and I'm not counting for everyone. Okay, what can we say? Okay, so I'm waiting for Utkarsh because he is taking a lot of time and he is particularly pointed out he needs time. How do we get him? It hardly takes 7 days or 3 days. Okay, so he is done. I am assuming everyone is done. So after installing a KiCad, this is the main. You need to extract the file, and here is the folder. You do not need it right now. So what you need in the KiCad, like let me delete this. Delete. Reset like this. Okay. Yeah. So when I are you it's finalized? Yeah, so the final date for the round one is 14th of the June for submission and themes will be released on 7th June. This is a new update. So you have to click on plus. You can write nickname. For example, you can write far away right now, and then you can save it, and then you need to click on library path. There will be a folder icon. You click on the folder, and then it will take to you need to select the main zip file which you downloaded. Here is a file. You need to go to extras, then you will click on the Scotto KiCad folder. Here it is. Then you will click on symbols. Then there will be a file called Scotto KiCads.keycad underscore sym. This is the symbol files. So this is the main file. When you will draw the schematics, this is the file that would be used. You can like write a description for it. It's just up to you. Okay. You need to click on OK. Then it will take some time. It is showing symbol, loading symbol libraries. When it is done, you need to click on preferences. Then you need to click on manage footprint libraries. So I have already added everything here. It's just like similar process. You need to click on, you can directly import them out. Then click on add existing. No, sorry, the folder icon, you need to click that. And for that, you need to again go to AutoCAPS, the folder you started extras, Scotto KiCad. Then you need to click on footprints. Then you need to select it all and click on open. So I have already installed it, so I don't need to install it right now. So I can skip it right now. And you can click on OK. It will be done. If you need 3D print, you can also do it, but it's not really necessary. You can just click on it and click on add. But let's skip it for right now. When you are done with this setup, let me know, then we will start. I am waiting for 2 to 3 done in the chat. Then I will start with the process of making the PCB schematics and everything. If you need, I can show it on the PPT as well if you require. After extract, what we have to open slash select. It depends what you are using. See, there are three things which you have to select. One of them is configure paths, configure symbol libraries, configure footprint libraries. So first of all, let me go it again. You need to click on configure paths. There are multiple things. For example, let me delete this right now. You need to click on plus new path. You need to name it. For now, I am naming it for example zoo. When I click on this, there would be a folder icon. You need to click on that. Then you will be taken down to uh, you need to go to particularly the folder which you have extracted. So this is the folder which you have extracted, Scotto keycaps. Then you need to select extras. You need to select Scotto keycat folder. Then you need to click on open. That's all you need to do in the configure path. My keycat is showing the screen. Next what to do. Just wait for a while. I will tell you. Remember, you need to do configure path footprint and symbols. Okay, when you do this path, symbol, and library, symbol you need to again, for example, let me rename this to Zoop right now. It will be much easier for me. So you need to rename. Remember the nicknames. Nicknames would be used in future. So set the nickname, select the library. For symbol, you need to select symbols. Then there will be a file called this file, keycaps.keycard underscore assembly. This is the file where all the Okay, so this is a file where all the symbols are saved. When you make the schematics, this would be used. So select on this. This is the thing for that. Then you need to click again preferences, footprint libraries. In the footprint libraries, it's much easier to use that. You just need to click on the folder icon. You click on that. You click on Scotto keycap main, the folder where you save everything. Click on extras. After extras, you go to again Scotto. Uh, I think I opened. No, so Scotto key. Uh, extras, and there's a keycat folder. Then you go to footprints. Then you select this all. This is the footprint libraries. It will be having every model, everything when you make the footprints and map out the virus. Okay. When you select, click on OK. So I think by this everything would be done. I think uh one of the person is done. I'm waiting for two more people. When you are also done, just write OK or something. You can start right now. After that, I will start. Okay. This is the basic process that you have to do right now. When you're done, please write I am done or something like that. Then only I can start further. I'm assuming two of the people have done, so I am starting it further. So then you need to click on files. You need to create an please explain where to put you can explain. Can you explain? Okay. Okay. So I think one GitHub repo you need to extract it. Then there are three options. Let me share you the PPT screenshot which are required. It would be much easier if you follow the PPT. Uh, nice. I'm re-going through everything. So when you download it as zip, you need to extract it. After extracting, there are three options: configure paths, configure symbol libraries, configure footprints. These are the things you need to configure first when before making the schematic and the footprints. For the PC, first option is configure paths. When you click on that, you need to name it. You can name it anything. For right now, I have named it Zoop. You can name it Scott or anything. Then you need to click on the folder icon next to the path. When you click on that, you need to go to your the extracted folder, then extras, then Scotto keycard. Then you need to select. You don't need to select anything. You can just open it because it's the entire folder that we need as path. Then second thing we required is configure symbol libraries. For it again, you need to go to the extracted folders, then extra folder, then Scotto keycat, then symbols folder. There would be a file called Scotto keycat. It would be the extension of the file would be Scotto keycat underscore sim. This is the file where all the symbols are stored. You need to just click on that and open the file. It would be saved in the uh, symbol libraries, and it will take a 2 to 1 minute or less than that depending on the system, and then you can use that. Then the second thing we have to do is manage footprint libraries. In that you need to go to again the extracted folder, extras, photo keycard, then footprints, and you need to select every file. You can just press Ctrl and select every file there and click on open. This is the entire process. When are you okay with now? You can write done and I can continue this. You can share the PPT. I have shared the PPT already. I can send it here, I guess. When please is done, I'm assuming now everyone would be done. So when we return to the keycard, you need to click on file. You need to make a new project as in any other software you will do. Do not need to change anything right here. Click on OK, and then you can make a folder here. But if you don't want, you can make in any path. That depends on you. So for now, I am click. You have to make a new folder. So here's a new folder for me. I'm naming it as uh PCB making workshop. Okay. You can name it anything you want. So what we are making today is basically we are making a 3 by 3 macro pad or 3 button macro pad, depends. Okay, so it is not made yet. Uh, uh, okay, so here you can name your file. For example, in the top it's same name. So I'm again naming it as far away macro pad dot keycat.pro. Don't change the file extension and click on save. So in here in this step, if you can see on the side project files, two files would be have been created. One of this is underscore PCI, and the other is schematics. So the PCB file is the file in which you route out the wires. So example, there is not much different. Basically the PCB is a circuit. It's even called a it's literally circuit. If you can see, I don't think so you would be able to see. There are particularly wire routed inside the PCB. A PCB are of multiple types, 2 layer, 3 layer PCB. So what is the entire point? It's like a wire sandwich between one and another, and there is between a insulation. So if you select the first layer you can select as positive, and second layer you can select as negative. And if you just join a LED, it will glow because of that. So there are multiple pieces. For example, in smartphone, the PCB that there is, it is 4 layer PCB. In laptop, there are sometimes 6 layer PCBs. So basically, what we are making is a very simple macro pad, something like this. So it would be 2 layer PCB. When you're done, you need to click on schematic editor. So it would be so. Let me show you the PPT. There would be a few of the things you will need. These are shortcuts which you need a lot. You will need a lot in this. So one of them is press. When you press A, the symbol libraries comes up, and the second is when you press W, the wiring came up. So we don't need the wire right now. And the second is when you press R, it's for rotate. So when you come back here, you press A, something like this appears. So for now, for making the even this kind of macro pad, you need a processor or the component that's microcontroller basically, which need this one is a little bit advanced. There is a screen and there is a rotator, so we are not using this right now. We are just using the switches and the microcontroller here. So I saved let we can use multiple. We can use RP2040 chip for like we can directly use the Raspberry Pi Pico, or we can use the Arduino. We can use multiple things. So for now, the most convenient one for me right now is Arduino. So uh, we can use the ES32. This one is so when you I save the nickname as Zoop. So there is a thing called MCU underscore Arduino underscore pro dot micro. So we will be using this for our project. When you like it depends on the what name in the nick there was a nickname option what you have saved in this, that depends on that. So I have saved it as Zoop, so it is showing in the tab of the Zoop, and it says MCU underscore micro. So this is a particular component which will have to click on OK, and just click anywhere on the surface. For zooming you, and additionally if you are using a mouse, for zooming in you need to scroll further, and if you need to go right and left, you can do it by right clicking and going here, and then you can also do a thing, press on control and zoom in further, so it will also go right and left. So for now I need to zoom it here. So if you see, actually if you check out the particularly how a Arduino Pro Micro looks like, Can we use STMCU? You can use a lot of things, but the convenient, like everyone is using particularly this chip right now, you can obviously use anything when you make your own hardware or anything. For right now, I will recommend using the same thing what I am using. So Arduino Pro Micro. See, here's the chip, how it looks in real life. The image is blur although, but I think that is enough. You can guess out. This is a better image. If I open it in new tab, it it shows the pin and everything. The schematics of the Arduino is easier. When you actually make a large scale produce a chip, something like that, you cannot have a USB, you cannot have the power LED. So for when you are making an actual PCB, not for the hobby thing, a lot of people what you do, this is the if you read the actual chip name, it is called 18 mega 32U4. So this is the actual chip name. This chip is also available right now. You can directly use this chip as well in your project. So we can I can't find the exact MCU. So let me tell you, when you press A, you need to search Arduino. Uh, You can also do a thing if you are not able to see for me as well, it is not able to come. So what you can do, you can search the nickname you save. For example, some of you have may said as name of Scotto. So you can search Scotto and it will be appearing in that tab. For me, I've saved the nickname as Zoop. So if I search Zoop, it shows all the things which is available in the Zoop tab. So you can just search Zoop. For example, I've set the nicknames of the Senpai libraries as Zoop. When I search Zoop, it shows me the multiple MCUs, multiple chips available, and you can just select from here MCU underscore Arduino Pro Micro and click OK. When you are able to find, just let me know once. PPT, let me share it. I think it's in quick now. Just let me know when once. Okay, done. Nice. So I'm also sharing the PPT link with you all. There is a PPT link as well. You can just, it is not very detailed, but it is a setup which you would be able to do very easily. So once you are done, here's the thing we need. And secondly, other than this, we also need switches. So if you search Zoop switches, so you will get a multiple type of switches. This is a normal switch, this is a key switch, this is a poly use. So what we need a particular placeholder under the key switch. You need to select OK, and here will be the switch. You can just click on this. Then you also need diodes because that is required. I'm not going into a lot of EC thing. So when you search diode, there would be a placeholder diode in Zoop as well. You just click on OK and just add it here. So uh, this is the first step. This is the switch. What we're making, this is a particularly switch. We are not complete. Yes, this is a switch. This is a switch and this is the diode. So what we are using the mass scale, you cannot particularly use the push button and a micromet. You will use the mechanical switches, the MX switches that we call. So when you click on diode and you need to connect it up here. So this is the schematic version of a mechanical switch which is available out in the market. I think there are no doubts. When you are done up here, you this is a particularly switch with a diode made and we need to connect it further. So we are making a 3 by 3 macro pad. So let me just slide it, and what you can do, you have to duplicate. You can press Control C, Control V, and you need to just place it, and there is a very step that you need to do because these will be connected further together. So we are going to connect it further. You need to align it perfectly in the side. So for example, uh, these two should be in the same line. It should not be mismatched, else there will be a problem, and the space between them should also be furtherly equal because we need to connect it column wise and row wise as well. And here is the second switch that we are going to connect. Uh, this is our row 2. We need to just go on further down so that this and this aligns and this rows align as well. So as we are making a 3 by 3 macro pad, the first row is done, second row is done, and this is the third row. If once you are done with this, you need to just check out this. There are multiple pins that are given here. So first you need to connect everything like this. So this is our column 1. This is our column. See, this is misaligned, which shouldn't be. This causes a lot of problem when you are going to connect it further. That's why I said don't. Uh, yeah, I think it's aligned now. Okay, this is column 2 and this is our column 3. Uh, this the space between the column 1 and 2 is different from what we are having in column 3. This is also done. So the switches are connected together in column wise, and then we need to also connect it in the form of the diodes. So I'm connecting diode wise. This is row 1, this is our row 2, and this is our row 3. Okay. I think there are no more doubts here as well. So when you have completed this step, you need to, if you read out the controller, like if you have any time worked with the controller, you would know how to correct this. So we will assign a row a particular point. So how keyboard or micro pad switch, everything is not connected to a particular point because we do not have ARS number point. If you for micro pad, you can even connect it with the PD1, PD0, second point to third point. But when you are making a keyboard, there are like 120 around keys. So you are not having a 120 connection which you can just connect out. So what we are doing in a column when we just press the, for example, when you press the switch button, the diodes is connected to the ground or something, the particular pin, then row is it detects which the S1 or S4 or S7 key is pressed, so it detects according to that. So you are not have to connect it individually. So when you are done here, you need to wire down this again. You can press W if this doesn't show, like if the wiring tool doesn't show up. Like for example, the wiring tool is not showing, you can press W, the wiring tool will start. So I'm pressing up here and connected my row 1 with pin number 5, or you can call it PD1. And for row 2 as well, I'm connecting it to uh, think so we should have to control. And another fact, you need to connect everything with one thing only. You cannot be connecting everything with multiple pins. And you have to use this PD, or you cannot use ground or PD3 anything other pin other than the pin which is that we can use. Then I'm preferring it to connect with another point PD6. This is connected. Then this is our row 2. You cannot cross it down. You have to make sure none of the wire is able to like mismatch with any other point. So I'm connected PD9. Then this is our third. I don't think so. We should be able to buy. So I'm connecting the column number 3 first. Then column number 2. we were connected. So your work is not done here. There is a electrical rule checking. Then there is a thing called assign footprint tab. So when you open the assign footprint tabs, the keycard doesn't know yet what thing is what for. For example, it knows this is the Arduino, but it doesn't know what switch and diode is doing here. So when you open the assign footprint tabs, it will take a few minutes because you need to synchronize all the footprints that which it is having. Mm, there is some yeah. Need to So when you are able to see here, the 90 number U1 is showing Arduino Pro Micro because it is assigned already. But for D1 is representing diode and D2, these are diodes and S1 is the switches. So it is not representing anything right now. So for D9 to D1, you need to assign a footprint. Here are the footprints which you need. So what you need to search out diodes. Yeah, you can search up here. There is a particular you need to search diode. There will be a multiple amounts of diodes. So there is a particular one which you have to use, which is named as myself. Okay, so this particularly with the 36 one which you have to use. Mm, this notion you can again we saved as photo. You can search that name and now diode. Okay, so it's now here. You need to select photo keycap component diode D035. This is the widely used and you need to click or double click on it. So D1, D2, everyone would be assigned the particular component which we are using for S1 to S9. You need to search MX switches. So we are using mechanical switches. So uh, you need to search MX. Then there would be a lot of things for it as well in this photo keycap as well. So we need to select the one you one, the particular one which you need to select is just select not it is not CAD one, it's just component. Then third yeah, it is saved as components. Let me go through it again. Like battery, button, capacitor, diode, resistor, LED. Can select K3 for right now. Double click on it, it will be assigned. When you click on apply and save schematic and continue and you click on OK. So everything up here, it is saved with the component reference. You can also click on electric rule check if you want, but it is just bit of waste of time right now. Just click on save. So this is the schematics which we are going to make. Let me see. Yeah, recording would be provided. So this is the particular schematics. Here is the main chip which we are using, and here is the switches with diodes. So when you click on the green icon, it says switch to PCB editor, and we need to switch to PCB because we need to route the components in the PCB. So once you open, it will also look blank. There is would be an icon with its wait a second. The keypad is not responding. You can close out the schematics although. Uh, yeah, so now there would be a button looking like this. If you can see, there will be button. It would be saying update PCM schematic. When you click on it, it will take a second and it will load something like this. And you just click on update PCB, close, and here's the PCB. Here's the particular thing which you have made. So the same zoom control works up here. You don't need to focus on these wiring inside the Arduino because this is the place where exactly the microcontroller is placed. We are using the Arduino for a convenience. So let's remove this. The switches is not came up perfectly. Let me just. So one of the feature of this keycard is as well you can directly sync. You can, yeah, this is being recorded. You can check out the recording afterwards. So as I was saying, we have selected wrongly the component for the switches. You need to again click on assign footprints and we need to search for the exact component which I am telling you right now. Let me check out. I think I have put in the PPT. Hmm, okay, so we have to select the PCB one up here in the assign footprints tab. So here is the thing for S12. Select S1 to S9, and instead of components there would be one named PCB, not hot. So, yeah, so here it is. Scoto, you need to select this Scotocap mx underscore PCB dot view. Okay, so you just double click on it, it would be reassigned. Click on apply and save. Okay, click on save. Then you need to again you can switch to PCB editor and just delete everything because we have strongly chosen the switches. To click on update PCB again, update PCB and close. Yeah, so now it is perfect. So the exact MX switches looks like something about like this, the square things. Uh, Here is the, but when you double click on it, this is the frame for a MX switch. I can just show it as well. There is a like power mode in Arduino idea. And this is a different thing. You are making a PCB. PCB is not using Arduino code or something like you are manufacturing a PCB itself. So next switches. So if you check out from bottom, it looks like this. There are two components in the bag. This one is a much better representation. There are two pins up here, and there is a hole up there for the pressing the spring action. So this is let me zoom it. So this is the place where which goes beyond. If you check out the PCB as well, there is a circle in between, multiple circles. So when you press, this thing comes up here because it has a spring action, so it takes a lot more space. And then there are two cutouts for this black, if you are able to see this and this. Then there are two horizontal, like very differently layouted in some other, like these two holes. These are the actual connection points in the mechanical switch. Okay, so has a predefined itself. So there's an additional fact. If you check out this, you can edit out the grids as per you. So for you need to use this one, which is 19.05. It might not be saved for you, but you can click edit the grid, and uh, you can add a new grid for the thing you need to add. Grid one as save as it's wrong, I guess. Yeah, so in the grid setting, you need to select 19.05 mm in the x-axis, and you just click on link, and it will save it. The y-axis would be same as well. It would be much convenient to place the blocks when we use the PCB. Then just click OK. OK, this is the thing. Great. So when here's the one of the most important thing which you need while making a PCB. So you can see the S1 is up here, S4 is S4 it is just mismanaged. So you need to first select the diodes and take it away. Then here is at the microcontroller. Select it out. So we need to align it up in a grid, proper grid. So the S1 is up here, S2, uh, select it. And this is not going further because we have chosen it a grid like this. You can try selecting it to the minimum value, then it will be able to move easily. You can go with consumer. Then the entire point is you need to align it properly, then so that when you are routing it, there are no problems when you are routing it further. So aligning it up here again. This is a little more time consuming part. So right now I'm not just doing with precision, I'm just lining it up. Uh, this is a line, then that is actually not a line. S6 is not a line. You need to pay focus up here and align it properly. Mm, so my S6 button key is not aligned, so I'm going to align it further. Uh, yeah, now S9. So we are making a 3 by 3 microcontroller, so we have 9 keys. And once we are done with this, yeah, so we are done with this. Now we have to arrange it. So when you are making a PCB, when you pay the cost for the PCB, it depends on the how much centimeter or how much length you are using. So for this PC particularly, if you are able to see up here, diodes are placed right here. So I'm saving up the cost for the diodes, and if you further see, there is a space between each. There are two diodes between each of the keys. So this is the far more complex PCB because diodes are placed in between the every key. So saving the space saves you the money as well, and it depends on how well you have made the PCB. So here's the diode one. So we cannot place it like this up here. So I'm pressing the R key and it will get rated. So this is the place I'm putting the diode. This is my second diode. The first I'm selecting it all and pressing R. So if you are able to see there are blue lines which are not like type of imaginary lines which is showing where what thing is connected to. So try placing it the as nearest as possible because it will be better. So the die you need to place the diode nearby, then let me place each of the diodes. Okay, so you can place the diodes as like wherever you want. I'm placing it further because I'm reducing the cost of the PCB. You can a lot of people just for showing off how well they have made a PCB place the diodes in an open space. Yeah, so diodes have been placed, and then the controller. This controller can be placed behind this. If it is not able to place, it will be showing the red spots. So right now I'm placing it up here because it is not a production PCB. So once you are done, there would be a icon like this, route single track. You can press X also for it. It will start the wiring tool. So as I said, this is a two-layered PCB. So we will put yeah, so this is a two-layer PCB. So we will use one layer up for our columns and one layer for our rows. So we first need to route this up. So I'm using the front layer for our. Actually, let's use the front for the rows. So you need to route the diode because diode is connected to the rows. First, the first step is this. Here also. For this, you just need to right click and you can connect it. And then you can see everything is connected up here. So you need to connect each diode in a row. Then it comes to this point. So I'm connected up this. Then this layer is connected like this. So as good as you manage out your routing, it will save you the time and effort to route each everything. So I have the space like this, so I'm using this. Okay. So once you are done, you need to route the column as well. So you cannot route the column and the rows in the same thing because of the like this is how circuit works. You need two different wires for negative and positive. The same concept goes up here. Then you need to there is a thing called B.cu. So this is a back second layer you can say basically. So I will connect the rows up here. Then this so there is a point additionally. For example, uh, I have made for example this is our front layer. So I can if I click on X, I can draw up a wire over the row. Okay. But if I select a front one, I cannot overcross a wire see because it will not allow me because you cannot connect a wire over a wire. That's it. Let me delete this. This will like just a waste of cost as well when you give it for production. So let's get back to the routing of the columns. Uh, this is the column X. Okay. So we need to connect our D6, D7, D8 with the columns. So the possible way showing is this way we can connect, but we cannot connect this way because the columns are connected like straight. So if you see the routing is not allowing me to do this. So what will I do? I will use the last column and go through like this and connect it like this. So I have done it wrong because when I will use this column, I won't be able to connect this because I will cross up the this wire. So I will draw this in the last. So let's make this first X, then connect it with D7. I can connect the D7 directly up here also. So for the column 2, I have to take a shorter path because I need the column 1 to be connected as well. Uh, I will take this way, then this. Okay, so I have made it very ugly PCB. If you check out, this is not a good sign when you are making the PCB. if the wire or the PCB get damaged up here, you cannot repair it. So be cautious about it. Then this is the column number 3. Okay, so we are connected, all connected. So there is also a very good feature if you click on view and you click on 3D viewer. So you are able to see the PCB which we have made. You can check out the switches available here, the second switch is there, and there are diode holes, and here is the hole for the thing. And if you are able to see, let me show you. Yeah. So if you can see the routing we have done, the routing is also visible up here. The color yellow, very faded color, but this is the actual routing which we have done. You can check that D0 is going up here and going through this diode. Uh, this is also a way you can just check it out how your PCB can download. You can't download this app in Windows. Please check. KeyCard you can download in Windows. You can literally, I'm using it on Linux. You can download it. Okay, so once you are done, if there is a thing called electric rule checker, uh, there it is. Yeah, so when I will run it, if any point is not connected, it will give me an error. So it is giving me these are errors, that is track unconnected end. So where it is, yeah, it will showing me the arrows. So as I said, this arrow, this is not required. So it is giving me an error. Just like this, don't need this. I don't need this as well. This is my mistake particularly, which is it is pointing out. Okay, so this is also a mistake which is pointing it out. X. Let me reconnect this entirely. This is giving me error for the extra wire which I have put also. That is the point, you cannot do such mistakes when you are making a PC, because anything you are doing, it can cause a short circuit and cause waste of the money that you have put in making a getting a PC produced from China or India itself. So when you are connecting it up here, so this is connected and more arrows. I'm not able to see more errors. So when I click on run DRC again, yeah. So now we still have errors. See, we have made this tiny arrows, and this is also coming it as a errors. Solved. Then yeah. So I think now we are done. I have shared the literal link of the software. How can you not able to download it? Copy link. We'll check it out yourself. Now, if we click on the learn electric rule check or design rule checker, I don't think so there would be any error. Yeah, so this is showing the edge cut error. So what basically our software doesn't know till now that there is where is the ending, where is the starting. So for that, you need to just select this any shape which you need, and you will just draw it up here. So yeah, press this. So this is the area where your PCB board will be. So Now if I will run electrical checker, so I don't think that there will be any errors. Yeah, so all errors are gone. Just now the entire PCB file is done, so you can check it out as well in the 3D viewer. Yeah, so for PCB, a lot of people, you can actually make a beautiful PCBs with the help of this. I can show it out to you. Uh, say you, if you require a particular shape, you can get it done in particular shape. If you are making a mouse, you cannot have a square shape PCB. You need a particular PCB in a particular shape. See, there's a heart shape PCB. So that totally depends what is the boundaries of your PC, what product you are making. So for right now, this is the best match. Then you need to click on file. Then export. You can export the STL or the file of the 3D print as well. But right now we need export. Yeah, you can save it as shaper as well, but we need it as zip. Let's check first of all what a software needs. So the best option to get your PC made is JLPCB, or for me what I use is all PCBs because it is much cheaper. I think all PCB has changed their name as well. Yeah, the new name is Avion. Avion PCB. Yeah, this is the same company as all PCB, so I got this PCB made from them only. So it will ask for the dimension of your PCB. So for dimension, what you can do, click on M. If that's not working, a lot of times there is a scale. So we just click on up here and we go up till here. So it shows 91.01. So we can select 92 up here, dimension 92, and our height is. Uh, See, this is a very random sketch. So height and everything is very random. 64.41. Okay, so we need the minimum quantity you get online is 5. Then you need to okay, sorry. You need to select the how many layer PCB. So for we are making a 2-layer PCB, you can also get one. And thickness. So let it be 1.6. The thickness is particularly how thick it should be. So as low as you get it is more difficult to make. So it takes another cost up there. Then it will ask you to upload the file. Yeah. So upload the JavaPC file. Yeah, so we can save the file as where it says fabrication output. We will save it as .gpr. Additionally, a thing that you can do up here, let me show you. You can click on text. This is just a way to customize your PC, and you need to click on self screen. So what is this? This will put your name up there. For example, I am writing you, so I can brand up here. So the same thing goes up for this. If you click on layer, there is a f dot cell screen and there's a b dot. So b is for back, f is for front side. So for up here, I write, for example, I need to place my Arduino in the back side. So I will write please, name. So I will write solder here. So if I will place up here, you can see the font is different. So if I click on view, 3D viewer, it says zoom up here, but it doesn't show place up here. If I will rotate this, uh, yeah, so it shows place here, this place. That is a thing. So for now, I will just export it in the JPEG. So this is the main file which is you send out to the fabricator. I will click save. It will ask me output. So I'm Save. Yeah, so this is done, and I will just click the Chrome upload file. Documents, where is file? Mm, You can also install a plugin. I'm going with a wrong method. What you can do in this, there is an option to plugin management. I think we should wait a second. So let's wait. It's yeah. So up here you need to search for something like fabrication. Yeah. So here is a fabrication tool. You need to click install on it and apply change depending. It will take a sec. Then you need to just close it. Then again, when you click on the PCB editor, I think we should like save it once and then reopen it. Save. Then now when we don't need this after now. We click on PCB editor. So there will be a new icon up available saying fabrication tool. You just click on that. Then just leave it like this. You click on generate and it will open up here. So there is a zip file which is created, and a do bomb.csv file is basically the file which includes all the component which you have used. So when you send out to a fabricator, you send out this file as well, so he can solder out the component. This you can use it for yourself as well. So yes, you're in the wrong folder. Documents. I think the right folder. Production, and there is a file called zip file. So I just select on it. It will take few seconds. It's analyzed successfully. So material type, it's although up to you. So material type, there is a lot of things such as FPC. There's the cable, the flexible ribbon cable. You say this is for that. You select this. We have layer two layers. Dimension, it will auto detect itself. Quantity, the minimum quantity is 5. Then for this thickness, 1.6 is the Hello, is it not coming for? No, it's coming. Okay. So where I have lost you all, can you tell me? Like, if you have any doubts, you can tell me. I think you would have done everything right by now, I guess. If you have any doubt or something like that, you can tell me right now. I can like help you further, or you can share a screen as well. I will guide you up to that place. It is not important to make hardware. It is just the rule that if you're making the hardware, you need to submit it in the form of PCB because the hackathon needs a proper hardware designs rather than just soldering up the Arduino everything. You need to submit a PCB proper made. If you're going with a software product, you don't need obviously a hardware. This is just a fact. If you are going with the hardware thing, you need a like I want a Raspberry Pi. And it depends on what you are making. For example, uh, for a last hackathon, I went with the hardware as well as software thing. So what I did, I made a Android version myself, and for that I made a PCB for my to run that thing on like a particularly a mobile PCB I made myself. So it depends on what you are making. So for example, if you are making a particularly device which is like a vending machine device, you can run it with the ESP device as well, but you need a jumper wire breadboard, you need a screen which is floating up, going the screen is going up there, soldering is getting broken again and again. So that is not what we need. We need a proper PC which has the screen inbuilt and the controller, the diodes, everything, and you need to solder it yourself, which I need. And if you are an additional fact is that if you are making something like that and the component which you're using, the data set is not available, you can just go out for this. So for example, uh I'm not able to recall. For example, you're making something like a slab. You're making a control. You need a very heavy set controller. For example, Arduino. The main Arduino Pico, not Arduino Pico, the Raspberry Pi Pico using RP2040. Okay, so when you search RP2 dataset, you will be able to find the data sheet up here. Sorry, I'm not presenting. I'm summarizing it once. Let me show you the thing what I was saying. If using RP2040 instead of see R5 Pico, see when you search up here, the Raspberry Pi Pico is a tiny fast micro board with around at RP2040. Okay, so the thing you are able to see up here, it is using the entire thing is used as soldering up the here and there. And if you see the black thing, that is the main controller up the here. This is the RP2040. Why do you need the entire board? Why you need to solder the wire and floating the components around it floating when you have the data set available up here? It's sometimes hard to read, but see, it indicates what is RP20 stand for. Here is a data set you can check out. When you see the chips, here's the thing. It says that this pin is for this, the first second pin is for GP00, the second and third pin is for GP01. You can just directly refer to the main controller, direct solder the component up here. This costs 20 rupees. If you go for a RPI, it costs minimum 80 to 200 rupees. It is cost effective, it is professional, it will just enhance your skills as well. The theme of the hackathon based on PC board, I am right. It is not based on PCB. It will be a very broad theme. For example, I say the theme is railways, and you are making a system, a device which is for collision monitoring. So for collision of a train, you need a device. You are making it, something like that. When you are making that, you need a hardware. You cannot just run it through software, right? So if you are making something like that, you need ultrasonic sensor. You need IR sensor. Depends on how in what way you are solving that problem, right? So for that, the base way, the minimum way how a person you use ESP or Arduino board, something like that. But it's always, if you see a project of how a school student makes a project. Arduino school project. See, this is the entire thing what I was saying. You can see here is a servo motor, and here is the distance sensor, and here is the point of the wires floating up here, and this does not look professional. When you are able to get the sensor dataset online, you are able to get the servo motor dataset online. You have the Arduino chip dataset online. Why are you making it like a school student? I think like you are mature enough to actually make a PCB. See, in this thing there is a single jerk and every virus here and there. How are you able to reassemble it again? It's still a breadboard. If you are going with a soldering, proper soldering, something like this, see, this guy has made a PCB for himself. I'm just telling you to use a PCB because that is the industrial standard. That is how normal things are made. Okay. I think I was saying that. See, this is how a student has made a project. I am just saying to avoid this and make a proper PCB. That is the entire point of making a hardware. If you are making a train collision system and you are making a hardware base for that, you cannot submit me something like this where everything is floating here and there. Okay, you cannot submit me a thing where there is a breadboard, there is a Arduino in a third hand, and you're just carrying it wobbling up here and there. You cannot submit there. You need to submit a PCB if you are making a hardware project. The theme is railways, and for example, you are not doing this. You are making a ticket booking system, so you do not need to make a hardware. That's very obvious thing. That is also summarize. Let for summarization, I have the PPT which I have made. Footprints. Yeah. I don't have, yeah, this is the form for the attendance submitted. If you will submit this form, then only you will get the certificate of the attendance of the workshop. Then summarize if I will go from up here. So what we have made is a PCB today. PCB is basically a circuit which you have made in the suppressed form, and it is convenient, it is cheaper, and it is a way how professional works. And I think in 1 to 2 years, when you work professionally in a corporate, you are not submitting something on Arduino, you are submitting a proper PCB. So submit out the attendance, this is the form. And if you have any doubts, you can, uh, I think I didn't share the screen. If anyone of you has not able to check out how or not able to make their PCBs, you can just stay in the meeting or text me on Slack or something like that, and I would be able to help you up there. And only if you will submit the attendance form, then only you will get the certificate. Please share the link in the chat. Sure. Here is the link.
Hello.
Yeah.
Can you please show the scanner print next to the attendance?
I have also shared the link in the chat and I think the PPT, okay, PPT is not sharing. Okay. Let me share it once again.
Yeah, okay, I just.
Yeah, if you're done and you do not have any questions about the workshop or far away itself, you can leave, or if you have, you can stay up. I will taking down so and everyone is done with the submission of the form. And if you do not have any doubts or any question, you can start leaving. There is nothing much more. I'm just taking the doubts regarding the workshop itself or far away. The link for the PPT I've already shared. Here's a link you can get. Uh, Copy link. I will just share the link. Okay, I think no, it is not share. I guess. Yeah, it is not. It's a chat. Here's the link for the PPT. I will also put this recording on YouTube private mode or something like that, so other participants who didn't join can refer to this. I think almost everyone of you have submitted, and if you have any questions or anything regarding, you can. There is a tab on the top ribbon, and it says Q&A. You can just put up there, and I can solve the doubts there. That would be much more better and not chaotic. If you have any doubts, then only just go up there. Otherwise, you can leave. Okay, let me check. I'm checking it. I've approved everyone and also sharing the link. Can I join? WhatsApp group is not in use as much right now. You can just Slack is the main communication because we have more than 10,000 participation and we cannot have that amount of people in the WhatsApp group. This is wait a second. Okay. Ashwik, okay. What is your doubt? If you can text or another workshop then also comes or not. This is the last workshop. There is another workshop on vibe coding which I will do this week or next week. I will post you for that. Ashwik, what is your doubt? Okay, you can start leaving if you do not have any doubts or anything. Yeah. Do you guys any doubt or something like that? Hmm. Dakshpuri, hello, Mahika, Moksha, Somil. Yeah,
Am I audible?
yeah, you are audible.
For round one, what we need to submit?
So for round one, what you need to submit for round one, the deadline for submission is 14th of June. So what you will do, 7th of the June, I will release the themes. So in next 7 days, if you are making hardware, software, anything, you need to make the MVP, the main product, the minimum product which you have to make. You can like put the features up there and say coming soon, but you have to submit the minimum thing that is your USP of your product, and you need to submit that. And in the you can submit in the form of PPT, or you can submit it in the form of a video, and you need to also submit the GitHub repo. You make sure you have made it public so we can see it. We are not taking the rights. We are just going to see through the code if you have actually coded yourself, or how much is the quality of the code. You can wipe code obviously, which is allowed. So we need GitHub repo, even if it's hardware, and we also need the software. If it's like the software, obviously we need a GitHub repo for that. And PPT or video, it's up to you. Can submit it in the form of video. You can submit it in the form of PPT, whichever you think it's better for us to review out your project. Any other doubts? I can end the meeting if you do not have any doubts or anything.
Uh, can you tell in a round one,
Yeah.
if I need to create hardware, so for that we need to create PCB on for before round one or like that. We need to
See,
only
see, see. If you are making hardware, let me show you the screen how hardware is submitted. Okay, that would be better for you all to know how hardware you have to submit. So, uh, so here is one of the hardware, like the PCB which I made. I learned myself how to make a PCB this March only. So how you will submit a hardware, you will make the repo. You need to submit the PPT as well, in which you will describe how the hardware will be made. So up here in the README, you will the title of the project, the features, the photos of the 3D photos which I was showing in the thing. You can make design the 3D thing in the Fusion 360 or any software you will like. Uh, this is the PCB, the schematic which we're making the blueprint. You need to submit this, then you need to also write a BOM file. So what you components you use in the thing. So it says 9 MX file switches, 9 keycaps, 9 diodes, one controller, screws, the 3D printed top tray PCB I made. So you have to submit all this. And if you check out the thing, there is a 3 to 4 folders. So the one of the folders is cat folder. So if you check out the cat folder, there is a case.stl and f3 that this is the Fusion 360 Fusion 360 file. So you need to submit the 3D models in something in a folder called cat, and you need to like obviously when you need a PCB with Arduino, you will use the Arduino IDE or you will use the quick firmware, yeah, circuit Python to make the firmware. So you have to submit the firmware in a firmware folder. So this is the firmware you have to. This is the main file the Arduino RP2040 uses. This is the main folder, and I'm using circuit Python. So there is a firmware.py file because my firmware is written in Python. Then there is a folder called PCB. So this is the file that my keycard generated. I need these files. Then there's the also production file, which is the production includes everything. This is the quick firmware, the keyboard.zip, and everything. The keyword.zip is the file that we uploaded in the fabrication thing. This is all you need to submit if you are making the hard project. Additionally, you need to submit a PPT along with it in the GitHub. You need to structure a folder like this. Okay, I think that solves your doubt. Then, and Python, yeah, I'm not technically giving out on the skills. What we are doing, you would need to know the Python because personally, me, I know the basics of Python, Java, every React because I vibe coded and because I do not vibe coded on lovable or sites. You like if you can see I have anti-gravity up here. Then I have VS Code also installed somewhere. Yeah, VS Code is in the tray. So how vibe coding works, you just give up the command, it will do. But you need when you vibe code, you need to make sure the thing is stable. The cybersecurity side is stable. There is no watermarks because one of the judges is from Microsoft, one of the judges is from TikTok, the app in US, and he is the senior manager up there. So you need to submit something like that. You can do not get rejected up there because they will review your project in the industrial standards, not on the basis that you are, oh my God, you are 15, so I will judge you on the basis that you are 15 only. No, you will be judged as the industrial standards only. So I will not give a Python. The next workshop is on that. Vibe coding, I will go with the React, but if it's on the vibe coding, I think it will be a similar way for the Python as well when you vibe code it. PCB design workshop take a lot more time than expected because PCB is the thing that AI cannot do right on. There is also a tool called Flux recently launched, but I have not used it yet, which can make the PCB from AI as well, but I do not have experience of that. Then, okay, so next workshop is on vibe coding this week or next week. I will let you know on that. What in that can give you a brief. We will make the UI from Lovable, then we will export it out and use it in anti-gravity or that software or VS Code Copilot. The vibe coding session, can you also tell how to generate good backend using AI? Yeah, that is the entire point of that workshop because anyone can make good UI from Lovable or Bolt or V0, but backend is not strong for everyone. So that is the point we will go through. And also cybersecurity wise, we will also go through that point because when a person from Microsoft or TikTok reviews a project, he will definitely check how secure a site is. He will obviously try to run few commands up in the console and he will get how poor or something, how you have made this thing, how good it is in the terms of security. Any more questions? Dakshmi ka Someli, Someli Mahika, I don't think. Okay, you two are there. I think you're just staying up here. You have just joined, but you are not participating or active. Okay, there is a question in Q&A tab also. So yes, already. That's why I'm ending up the session.